So let's see. It seems like it's okay, pretty good. I guess this is look at the distribution. Looks like a um, decent one. Um, so let us go over the questions one by one and see if any further discussion is needed. After that, we will have a break. So let us go to quiz 5 and 6. That 10 questions. I hope you can see the screen. Can you see the screen? Yes. So let us do the question. So the question 1 is the company has average salary, right, which is 2.8 million, right, per year, right, average salary with this one, right? So which means that let me open this. So let me open the drawing. Okay, so what is said is the expected value of x, right, 2.8, right, and the SD, right, is 1.2. Okay, so mean the variance of x is 1.2 squared. Okay, so the sample size n is 100. Okay, so what is the standard error, right? So which is SD, right, over root n, right? So standard deviation is 1.2 million over 100. Okay, so it's 0.02 million. So the answer is B. Is that okay? For the first question, is that okay? Is that okay? So the second question is the mean score of exam has this, right? And has division and the division of 3, right? So 60, right? So the mean is 60, right? Standard deviation of 3, right? And it's 36, right? And asking the mean score is bigger than 61, okay? And what we do is invoke the central limit theorem, which x bar has normal, actually, to fit our notation. I should change the mu 60. So 60 is 9 over 6. Okay. And so then we will have 61 minus 60 over 3/6, right? So it's probability that z is bigger than 2, right? How do we do that part? Right, this will be 1 minus norm s this 2. Okay, is that okay? Is it okay for this part? And then we will go to the next question. It is said that the weight, right, weight as normal with mean 2, standard deviation 0.1 square, okay? And sample with that is n is 12, right? So what's probability sample mean is between this, so it's asking probability that sample mean is between 2.01 and 1.99, okay? So then you convert to z-score, right? So this is equal to probably that is z is 2.01 minus 2 over. So this is imply this normal 2.1 square over 12, right? So that's means 0.1 over 12, 1.99 minus 2 over 0.1 over square root of 12. Okay, so that's the answer, or we can show you in the let's show you in the Excel spreadsheet to get the same time to show you how do we do that. Okay, let me show you this particular question and show you how do we handle it in Excel spreadsheet. So how do we get the answer B? So let's find out the Excel. Okay, so the mean is 2, right? And then the SD is 0.1, right? So standard error and N is 12, right? So standard error will be the SD over square of N. So let me copy the answer. So this mean, this is the SD, it is N, so this is an error. And what we want is between 1.99 and 2.01, right? So let's divide in 2 parts, right? Let's calculate this, right? And 1.99, right? So how do we do that part, right? So you calculate the z's first, right? So basically is you want 2.01 minus 2, which is the mean, divided by the SE, right? So this is there's a 2z value. 1.9. Okay, so then this is a z value. So I would do the norm standard, this 2. Okay, and there are two values you want to find, and the difference of the two, right, will be the answer. Okay, so let's see. Let's see whether you know how to do that part. Is that okay? Is there a question? That's how you get one. No question. Okay, good. So let's go back to the, so that's how I get this answer. Okay. So the next question will be the proportion, right? Saying that 40% of students are afraid of dogs. Okay. And you take n, right? First, you see the n is 40. Sorry. Pi popular proportion is 0.4, right? And the random sample n is 20, right? So you see n pi and n1 minus pi bigger than 5. Okay, so we can use a normal approximation, right? Because the question is, then this will be the following: p, the sample proportion, will be normal distribution with 0.4, right? And this will be 0.4, 0.6. Depend on n we have is 20 here. Okay, so if a sample of n, the n is 20. Okay, so this is the sample proportion will be, right? So the question is asking the proportion is between 0.41 and 0.39, right? Okay, so as we can see, this is already the 0.1095. Okay, so that means what we have is z is 0.41 minus 0.4 over 0.1. So this is square. Okay. 0.095 and 0.39 minus over 0.4 is 0.1095. Using the same method we have just shown, we can calculate the answer. Okay, so is that okay for this one? Okay, let's okay, some people ask the same answer, so let's just go over the question again. So pi is 0.4. Let's do it in the Excel. Okay. So let's do it in Excel. So I guess some of you have a question about this part. So pi is 0.4 and it's 20, right? The question is asking probability that it's 0.39, p 0.41. So this is the question. Okay. And the first part is the sample proportion. P is 0.8, right? Which is just equal to this multiply this guy. Okay. And the sample, this is the sample mean or the EX, right? this sum of proportion, that should be fine. And we want P1 minus P over N will be the variance of the mean. So that's why we need some 4.4. So will be equal to 0.4 times 0.6 divided by 20. Okay. And this we will take the square root of that, right? So, right, there's a question. Okay. And we take the standard error, right? With the square root of that. So it's 1.095, that's fine. So we want the probability, right? So we want to have a probability that is P is less than 0.41, right? So what you do is to say Z is less than what number is 0.41 minus 0.4, right? Divided by 0.95, right? So what this actually is 0.41 minus 0.4 divided by this guy, right? It's 0.9128, right? So then what you do is look at this norm this, so norm as this, and then this true. Okay. And then this is 0.39 is P, right? Then you have this, but now you have 0.39. Okay. Actually, the answer will be similar, but just 0.39. Okay. So you get this, get the same, then you take the difference. I see. Some way one thing right. This is a little bit different. Let's see. Maybe a typo. No. I see. So it should be, I guess, a typo here, but yeah. Okay. So it seems to me that yeah, there's a typo here. Excel is correct, but I guess the answer is not right. So, but I guess this will be typo that I have the answer here. So it should be one more zero here. I guess that's the reason why I gave a mistake. So it should be this is right. So it should be for some reason. Yeah, I think it should be that should be the right answer. Okay, sorry for the mistake. I guess that would be. I think that should be. Now it's correct. But I guess this should be. I should change the answer accordingly. But that should be fine. Otherwise. Something like that. But anyway. That should be. Sorry for the mistake. I guess otherwise it's correct. Thank you for pointing this out. Is it okay now? Yeah, I'm sorry about that. So for the next one will be, that would not be too difficult. It's asking margin of error. So ME is, ME, right, will be Z of alpha over 2, right? Because we know this sigma over root n, right? So 90%, okay? Then we look at Z of 5, why? 9, why is it case? I don't know what's going on. So we want a 90% interval. Oh, sorry. Okay, the mean. So what we have is the economist, right, saying the standard deviation sigma is 1,000, and n is 50, and mean income is this, so x bar. Okay, what is margin of error for 90% confidence level, right? So that's margin of error will be z alpha over 2 sigma over root n. Okay, and 1 minus alpha is 0.9, right? So alpha is 0.05, right? So z 0.05, right? It's like this. So we want the n is 5%, right? So accordingly, the left-hand side is 95%, okay? And the function that give us what is this is the f is the inverse, right? With norm, norm standard inverse 0.95, okay? That should give us the 1.645, okay? So this is 1.645, and this sigma is known to be 1,000, and root n is 50. Okay, so should give you 232.6. Is that okay for this one? The same question, actually the same, everything the same, except if with here before we have the margin. Okay, so that's the same question, but now we change to the width. Okay, and that's why 2 times of that. Okay, and the question 7, is that okay for the question 6? So question 7 will be asking the similar question, but we have the we don't know the sigma. Okay, now we know the sample standard deviation, that's S. Okay, so the margin of error, the formula, right, for the sample mean will be T alpha over 2 S over root n right? So, sorry, I should be a little bit more careful because T, I need to write down the degree of freedom, which is n minus 1. It's the formula, right? So it's T7, 95.025. Okay. So if you do Excel, will be the T inwards, right? 0.975. Degree of freedom is 7. Okay. And S is given by 140 and N is given by A. Okay, so that's how you get the marginal error. Is that okay? Okay, no question. Then the next part will be the little bit more tricky because I don't give you the answer directly, right? Because I'm asking proportion. So sample item 30% defective means the sample proportion. Right? P will be V 30 over 300, which is 0.1. Right? Here, sample size, N is 300. Okay? So you know the sample proportion following normal distribution, right? Because we have NP times NP and also N1 minus P are both bigger than 5. Okay? So we can have, because the sample proportion is 0.1, this is our point estimate, right? This is our way to guess, right? And that would be the interval estimate, right? We would have around this, and that will be the 0.1, right, times 0.9 divided by 300. Okay, so the confidence interval will be 0.1 plus minus z alpha over 2, okay, square root of 0.1, 0.9 over 300. So this is the marginal error. 90%, this is 1.645 or 1.64, depends on what you do with the 5. Okay, so this turned out to be 0.028. Oh, I guess yeah. So the I guess some of you have asked the question. I forget. Oh, I see. Some of you asked why the question egg is too large. So it should be. Sorry. I guess that would be the reason why people have question about this question. Yes. Sorry for that. Sorry. I guess that would be some question about that part. Yeah. Sorry. I hope now it's okay. Sorry, someone asked me there's a question. The question actually, I now notice what is being said. Yes, thank you. Now it's clear. What's the question? Okay. Any question about that? Good. So here, the last two questions will be just applying the formula directly. Sample will be the z alpha 2 square and sigma square over me square, because asking a sample mean. Right? So that's why it's 95%. Okay, it's 1.96 square 150 square. Margin of error is between 50, so it's 50 square. Okay, so should get you this number and should run up to 35. Okay. There's no question. Then go to the last question, which is the population proportion, right? Believed to be 0.4. So pi. So 1 minus alpha is 0.95. Okay. Sample of error ME is this one. So n is equal to z alpha 2 square pi 1 minus pi over me square, right? So it will be 1.96 square 0.4 0.6 0.6 over 0.03 square. So this should be the answer. And that's why one up, we need this guy. Is that okay? Okay, let's have a break. Sorry, this is a little bit taking too long. So let's have a shorter break. Let's have a break of 5 minutes. We take a shorter break. So let's resume at 11:46. Hi, I guess we should resume the class. So just some announcement first. I guess many of you know that our 2000 and 3000 classes will be remaining online for the rest of the semester. So now we know it, so that's we will fix our exams days and also the projects stuff. So I guess given the current situation, we will continue to have exam as scheduled. We tentative schedule is 26th of November. Okay, so I will send out the announcement later, but that would be the goal. Will be at night, tentatively 7 p.m. to 9 p.m. for 2 hours. The reason why we need to be that late because there's a time difference between here and other people in other places in the world. So make sure that try to minimize the time difference. I hope that should be fine with you. I send out an email and you open book. This will be sent to you by email and announcement. It will be a 2-hour exam open book, and you write down your answer, type your answer, and then you submit online. Okay. So different from the current class, we don't require you to put your video on. For the exam, you need to put your video on. Okay. To let me proctor you. If you are away from the desk, you have to report. But anyway, that would be the detail. And if you happen to be away with official reason, then you have to declare first. You get approval, then you'll be given the makeup afterward. Okay, but it will not be accepted if you don't announce early. Otherwise, the makeup will not be available to you unless you have prior approval from me that you get exemption, then you can get makeup. Otherwise, there's no makeup. Okay. And for those of you who want more exams, you can see the quiz. We have an assignments we are going to give you. And also you can check the past paper from the library. Okay, there's a lot. Those you can take a look on those. The possible question that I may make from those. I will check out the exam papers from the other section. That would be the basis that we make exams. Okay, any question before we start? No? It's okay? It's okay, right? In that case, if no question, we'll continue. So this is, say you go to the library, you can download this kind of, for those who don't know, we download this kind of question. Then somewhat like this kind of question is probably, I guess, we're at the same level of this kind of question. So probably we are going to you don't need to turn on your cam now, but for the exam, for the test, you need to turn on it. Is that clear? Not now. No need to put it now. I mean, there's some way to make sure that you don't, I mean, I need to invigilate, right? Is that clear? Shall you? Yeah, not for now. You don't have to open the, yeah, not now. Just, and also you need to turn it on for the turn on for yourself for the group presentation. That's it. I think there's only scenario that you need to switch on your cam. Okay. If there's no question, then we will continue but I will send more detail, for example, for you in email. And also, I think also the project, some project, we talk about that more. Okay, if there's no question, let us try to finish the one sample test. I guess that would be the goal of today. I guess we might not be able to finish it, but doesn't matter. We almost finished it, okay? So to go back to the example we have, let's start with example. I guess that would be easiest to connect yourself with example, okay? So let's connect example here. So the question is, we have a hypothesis testing class. Last class is trying to see, we try to test this claim. Someone claims it is equal to 4, okay, the mean. And you have been decided that what you would want to have otherwise is bigger than 4. Why this is the case is because for some of the time, you only want to reject when it is more than, right? Say mu is the, say, harmful substance in certain food, right? So you would want to reject if it's more than certain level, right? If less than is fine. Less than harmful substance is too low, we don't have a problem, okay? So what you're going to do, just remember, okay? What you do is you assume this is true. So what you assume is true, we also know the sample standard deviation is 4. So we can draw, we know X bar, we have the normal distribution with mean 4, right? When the sample size is 64, right, will be 64, sorry, will be the 4 square over 64, right? This is the what the sample mean would have a normal distribution, right? According to central limit theorem, right? So it'll be something like this, right? It's 4, okay? What happened is now is we figure out this is 5, okay? And then we're saying 4, right? 5 bigger than 4, right? Clearly it's not supporting equal to 4, right? So how far is further than 4 to say this is too large to say this is within 4, right? So we will say, when we test it, we say, okay, if this is, we say alpha, right? If, or we have a predefined area, right? We call alpha, right? Maybe a blue area, say alpha, okay? If this alpha, we would put, say, 5%, right? Say if this probability is too small, right? And this is alpha is a threshold, right? If the red area, right? If the red area, okay, is less than 5%, right? So which means distance is large enough, then we will reject this, right? So there are two ways to do it. First is exactly find out what is this area, right? So that is the p-value method, right? So that what you do is you would convert it to the z-scale, right? This is 0, right? 4 becomes 0, and 5 become 2. How do you do that? You subtract the mean over this, right? Because it's this. You just convert z, right? With 0, 1. Okay. So this is 2, and you want to carry this area, right? This area calculated by this p-value method, right? Which is 1 minus norm as inward this 2, okay? So give you the area which is far less than 0.05, okay? So that's why it is too small, and that means 5 is too distant from 4, so that you will reject the claim that is 4, okay? Alternatively, oh, sorry for the mistake, it's just not, okay? Alternatively, you can look at the blue area, okay? And if you want 5%, right? So this is 1.64, okay? This is coming from here. This is coming from the norm S inward 0.97, 0.95. Okay, do this. And you figured out 1.64 is left of 2, right? So that means that this area is 5 and the purple area is less than 5. So that's why you reject. Is that okay for this one? Okay, this is something we covered last time. So similarly, we have the question where less than, right? So the same question, right? Sample mean, population variance, and sample size. That now is equal to 4, right? Again, the question is, if the null is true, right? This is 4, this is 3. Is this area small enough, less than the alpha, less than 5%, right? So we figure out that the z, this is 0, and this is 2, right? And we know that this is less than 5%, right? It's 0.0228, right? Alternatively, you can check, so this negative 1.64, okay? And this is the 5%, okay? So on the left-hand side of that, right? So that's why it's just, you would reject. Is that okay? Any question? Okay, if and now the little bit combine this part is asking instead of equal, no, instead of saying this and more than or less than, you're not equal to, okay? The reason why is, say, this A, and we want to reject on the both end. Why that's the case, right? Just to remind you why you want to reject if you're too far away from A, from both sides, is because the accuracy is very important, right? You have to exactly in A, otherwise it will be a problematic thing, right? For example, like the active ingredient in drug, in medicine, right? And you'll be exactly at that content. Otherwise, if too much, then it will kill the patient. If too less, it will be ineffective, right? So the drug, you need to exactly equal to A, okay? Or for auditor, you have to be exact for that number, right? So, and that's the idea, okay? You divide. Remember, alpha is 1 minus alpha is in the middle, right? So this is 1 minus alpha. That means that both sides, okay, you will be assigning alpha over 2, okay? So if I use 95% as usual, okay, so that will be 2.5% on both sides, okay? So that is the tricky part of the left hand or right hand and both sides, okay? And do note that the p-value will be more tricky, okay? By definition, the p-value, okay, will be, when you calculate, will be 2 times of what you find, okay? So that is the definition. It's 2 times the area. So suppose you would say, if you find out this is the value you figure out, if this is the area, you're the 2 times of that area, okay? So that is the something that is by definition, okay? There's nothing, no reason why the period is, but this is the way we handle the subject, okay? So here there's a typo here. There's more than, okay? So here is the, again, the question, X bar. According to this question, according to the hypothesis, this is 4. Okay, it's 4 here. And sigma is 4. Okay, but this we have sigma over root n for the standard error. Okay, that is 4 over 64. Okay, so it's 1/2. Okay, again, we figure out that the sample data is x is 3, so it's here. Okay, so the question again is asking, is this area and both sides, right? So what you do is actually asking, this is distance 1, right? And this is also distance of 1, you get 5, okay? You are asking, is this combined area, okay? Okay, or the combined area is less than alpha, okay? To put it this way, right? Is this the middle one, 1 minus alpha, right? So you have to see whether it is less than, compare this to the C space. This is 0, right? You want to check the C space, right? You want to check C alpha over 2, Z alpha over 2. Why? Because this is alpha over 2, and this is alpha over 2, and the middle will be 1 minus alpha, okay? So you convert this 4 into 0, and 3, okay? You will convert 3 into 2 here, -2, right? And 5 will be +2 here, okay? So you would see that this is equal to 1.96 negative. This is equal to 1.96, okay? And the actual one you find is 3, right? Which means that this area, right, both sides add up together is less than the alpha, 5%, okay? So that's why you reject. Is that okay? And the p-value will be, you calculate this area, you multiply by 2, okay? The reason why not by 2 is you want to compare with p directly, the alpha directly. So you just like to see whether alpha is bigger than p or less than p. Is that okay for this one, the two-sided? It's similar, but a little bit trickier. Is that a question? I hope that's okay. It's not. It's a lot more like procedural stuff. It's not something like you don't understand, but just basically just how to apply the formula directly. It's like more procedural. I think the idea is very simple, right? Just like if it's too far away from both sides, then you reject, right? So because you don't know where, then 1 minus alpha is the middle, and you put totally alpha on the both sides. So it's alpha over 2 on the both sides. And if it's too far away, then you say reject. The same idea. Is that okay? If there's no problem, then we go to the next, okay? So the only thing we know is we have no idea about sigma square, okay? Instead, we use S square, okay, to do that, right? Because remember, this is the summation x minus x bar square n minus 1, okay? Remember n minus 1 here. And if you do this, we know this is going to be the t distribution with degree n minus 1. Okay, so this is what we learned from the sampling distribution chapter. Okay, so everything will be same, but instead of z, okay, you will become tn minus 1. So everything will have the same method. Okay, so let's see you will see the same question again, so don't worry. So now I deliberately make the same question, N16, X bar is 5, and S is 2. So the sample variance is same as the population variance. Okay, I deliberately make the same number, but you will see the logic easily. Okay, so you want to test this against this one. Okay, so against the right tail, so you just say X bar, right? This is 4 here, and you would say you want to reject if this is far from 4, right? Far above from 4, right? If far above from 4, then you say reject. Okay, say if this is this rejection region, right? If this, you figure out if this is alpha, right? It is usually you would do the 5%, right? So it is way above alpha. So you want to know what's this number, right? Of course, you can calculate directly, but let's do the standard way, right? So what you do is convert this to the t value, right? Again, this is 0, right? And remember, you figure out this is 5, okay? So somewhere, I don't know, 5 is, I don't know, it's where, maybe here, right? If 5 is here, then you are okay, right? Then you will reject. If 5 is here, is outside this extreme region, then you would not reject, right? You do not reject if this is here, right? So now let's see whether 5 is this or 5 that, right? Or look at area 5 is more than alpha or less than alpha, okay? So let's see 5, okay? And look at 5, go to the t space, you minus 1 over the standard error, okay? Because standard error, okay, is 2 over root 16, right? So it's 2 over 4 is 1/2, okay? That's why that's what we have. And this turned out to be, this is 2, so I should have 15, okay? And now what you're going to do is you want to see the 5% is where, okay? Turn out that, okay, if you look at T 15.05, okay, from how you get this number is T inward, right? 0.95, and you put 15, okay? Excel have a little bit reverse where you put the probability first and then you put the degree of freedom, okay? To give you this number, okay? So what the Excel means is 1.735, and that is 5%, okay? So which means that the area above 2 is less than 5%, okay? So you would say this far away from 0, that means 5 is this scenario, far away from 4, right? So that's why we reject this at the 5% significance level, okay? So this we are done, okay? Alternatively, right, this is less often we use, but now we have Excel, then it's very often we can check directly. Look at this, okay? Look at this 2, okay? What's area this, right? We said less than 5. Can we calculate exactly what the area is? And you can use 1 minus T this, right? I think it's 2. You put 15 here. And then you put true, right? Okay. And this will be the Excel solution to this. okay, which is less than 5%, it's 3%, so that's why you would again reject. Is that okay? Any more question? Okay, if no, then we will end our class today. So I will see you on. Someone asked me, will you know whether one tail or two tail? Of course you will know, right? Because either you'll be given the external X1 or you should infer from the question, right? Just remember, if the first thing is you don't know which side is correct, then use two tail, right? And if you know that the violation, the consequence is you want to check whether it's more than, right? In the case says harmful substance, right? It's more than, then you infer more than, right? If they say you are saying how many, you are checking whether a candy, right? About a candy, if it is less than that, will be problematic, right? Then you less than. It depends on situation. If I don't give you correctly, you have to infer by yourself. Otherwise, you'll be given. Okay, you're going to make decision on one tail or two tail. I think it's very clear what you to do, but otherwise, it should be clear. Okay. If there's no further question, then I'll see you on Thursday. I'll send you an email in the meantime about the exam, and also we'll talk a little bit more about the project, but I guess that should be all right. I'm asking the TA to do the peer grading, yeah. So hopefully, I haven't seen him for a while. I'll try to talk to him. Yeah.
Professor，我想問下，關於頭先個 quiz 嘅第3題。
好。quiz 嘅第3題。Yes。
我想睇一下你係點樣 gen 個即係 Excel 嗰度，因為我最後計到咧係0.00027咯，跟住之後我唔知係咪，但係你嗰個0.27，我唔知我邊度出咗問題，可唔可以 show 一次點樣？
我 show 個 Excel 點樣做咧，好嘛？
好啊，唔該你。
show Excel 點樣做？睇先，你睇到嗰個係我呢個 screen 冇問題。OK， 咁我開個 Excel。咁即係話 ，OK， 佢即係話 μ 係4啦，咁 SD 就係即係sigma就0.1啦。
係。
即係咁啦嚇。咁跟住 n 就係12啦。OK， 咁首先計咗 SC 先啦，係嘛 ？SC 即係話 sigma over root n， 即係 this over square。呢個 OK 嘛
？OK 啊，我都計到。
咁而家佢問嗰個 X bar 係1.99，係嘛 ？X bar 2.01。
係。
咁即係我首先要將佢 convert 做 z 先啦，係嘛？即係如果 x 等於 1.99 convert 做 z 係幾多咧？咁即係話個面係2，個面係2係嘛？個面係2啦。
係。
咁即係話個 c 就係1.99，即係1.99減2，除翻個 standard， 呢個 OK。咁呢個 c x 等於2.01，咁等於 c 係幾多咧？咁即係又係一樣啦，2.01 減2除翻個 center 啦。咁而家就將個 z 即係話，即係所以就係變成負0.346 z 0.33464啦。係。試下得唔得意？等先。咁跟住我就咁即係話我要搞個 norm as this 呢嚿嘢 true 啦，係嘛？
係。
咁所以我應該係呢個減呢嚿嘢。咁得唔得？咪就係270，應該冇錯啦。
係，我知我自己邊度錯，我計咗0.1除咗，即係我睇錯咗嗰個係0.01咯，呢度係0.1。唔該晒。
咁都冇問題啦，係嘛？
係冇問題。
唔該晒。
唔該晒，Professor，拜拜。
拜拜。